Alright, this is 7.4, lesson part 1, adding and subtracting radical expressions. Now, what you do with radicals is you treat them like variables as far as like terms. So when I have the expression negative 3 times the square root of 200 minus 5 times the square root of 8 plus 9 times the square root of 98, these radicals, these square roots are all different. Well, they are until you simplify. So let's go ahead and simplifying them. Now remember, when you simplify radicals, you're always going to factor tree and factor out the smallest thing. This way they're always grouped together. So 200 becomes 2 times 100, which is 2 times 50, which is 2 times 25, which is 5 times 5. We're looking for groups of size 2 because it's a square root. Here's one group, here's another group, and then the 2 didn't. So I have a pair of 2's, a singleton 2, and a pair of 5's. So I'm going to get negative 3 times 2 times 5. In other words, negative 30, and then the square root didn't go away because I have the 2 left over. Now let's look at the next term, negative 5 times square root of 8, which is 2 times 4 and 2 times 2. Circle the group of size 2. I can pull a 2 out, becoming minus 10 root 2. And then lastly, I have the last term, 9 times the square root of 98, but that was 2 times 49, which is 7 and 7. I can pull out a 7, leaving behind a 2, so it becomes plus 9 times 7 is 63, square root of 2. Alright, so again, I factor tree. I look for things, I circle the things that are in pairs because I'm doing a square root. Each pair means I can pull one of them out. So on the first term, I had a pair of 2's and a pair of 5's, and I already had a negative 3 on the outside. So that becomes negative 3 on the outside, times a 2 on the outside, times a 5 on the outside. When I multiply those together, I got negative 30. Similarly, I had a pair of 2's, so I ended up with negative 5 times 2 to get the negative 10, square root of 2. And my last term, I had a pair of 7, so I pull out a7, so we multiplied by the 69 to get 63. Hey, wait, do these now end in square root of 2? They do. So I just combine the like terms. Negative 30 and negative 10 is negative 40. Negative 40 and 63 is positive 23. And then I had negative root 2 as the term. Alright, now I'm going to do the same thing, but for the variable. Now, here I have the 4th root of x to the 7th. Alright, well 4 goes into 7 once, so I'm going to pull an x out, and I'm going to leave behind 3 x's. In other words, if I factor treed, I have x times x to the 6th, x times x to the 5th, x times x times x times x times 1, 2, 3, 4, 5, 6, 7. I'm looking for groups of size 4. So there's 4, but I'm leaving 3 behind. So I pull out one of the x's to leave 10x square root of x to the 4th root. Same thing here, except here I can't take anything out because there's only 3 x's and I'm doing a 4th root. So it's minus 2x 4th root of x to the 3rd. Now, do you see that this term is a 4th root of x to the 3rd, and this is similar, 4th root of x to the 3rd? That means they're like. So I could do 10 minus 2 to get 8x 4th root of x to the 3rd. So, recapping, anytime you have a radical, you're going to treat it like it's a variable insofar as like terms are concerned. And you're always going to have to simplify them like we did earlier in chapter 7.